Quadrants are the four regions created by the intersection of the x and y axis. Let's proceed. Now for our first quadrant, we are going to have A. Our second quadrant, we are going to have A's. Our third quadrant, we are going to have T. And our last quadrant, we are going to have C. Now to recall this, you can as well say all students take coffee. Now for our first quadrant, what this entails is that both sine, cosine and tangent are all positive. So you are going to have that your sine is positive, your cosine is positive, your tangent is also positive. In your second quadrant, it means only sine is positive. So this entails that our sine is positive, our cosine is negative, our tangent is also negative. Proceeding further, our third quadrant explains that the tangent, which is t, is positive, which entails that every other thing is negative. For our last quadrant, we are going to have that only our cos will be positive. So from here, we are going to have that sine is negative, cos is positive, while our tangent is negative. Pythagoras theorem is one of the most fundamental theorems in mathematics, and it defines the relationship between the three sides of a right angle triangle. We are going to label the base as A, then the longest side as C, and of course, we are going to label the opposite as our B. So the rule states that the longest side, which is our hypotenuse, is always equal to the sum of squares of the other two sides of the triangle. So from here, we are going to have that our C squared will be equal to A squared plus B squared. There is something called SOHCAHTOA. You want to be familiar with this abbreviation. So from here, our A's denotes sine and our O denotes the opposite, while our H denotes the hypotenuse. Hence, we are going to have that sine theta will be equal to opposite over hypotenuse, O over H, which means opposite all over hypotenuse. And from here, our opposite is B, while our hypotenuse is C. Moving forward, we are going to have cos theta, which is equal to adjacent over hypotenuse. And the base value there, the adjacent is A, while our hypotenuse is the longest side, which is C. Now there are some other formulas that you need to be familiar with, which include sec theta, which is equal to 1 over cos theta, cosec theta, which is equal to 1 over sine theta, cot theta, which is equal to 1 over tan theta, and of course, our tan theta, which is equal to sine theta all over cos theta. This further implies that our cot theta can also be represented as over sine theta. This question reads, if sine theta is equal to 3 over 5, find cos theta. So from here, we are going to find cos theta. Recall, We'll start by drawing the right angle triangle. But recall that our sine is given to be opposite over our hypotenuse. So we are going to find the opposite. The opposite here is given to be 3 in the numerator from the question, while our hypotenuse, the longest side, is given to be 5 from the question. These are angle. It means that the opposite is 3, while the longest side, the hypotenuse, is 5. Now we are going to find the adjacent, which will enable us to find our cos theta. Now from Pythagoras theorem, we have that the longest side, which is c squared, is equal to a squared plus b squared. It therefore entails that our 5 squared will be equal to 3 squared plus x squared. We are going to make x the subject of formula by making it stand alone. This entails that our x squared will be equal to 5 squared minus 3 squared. Proceeding further, we are going to have that our x squared will be equal to 25 minus 9, and this is going to yield 16. So from here, our x is going to be equal to square root of 16, which is equal to 4. We are going to redraw the triangle and put 4 in place of x. From here, we are going to have that our cos is equal to the adjacent all over the hypotenuse. So from here, this entails we are going to have that our cos will be equal to 4 over 5. So therefore, cos theta will be equal to 4 over 5. But what if we are told to find cosec theta? We are going to have that cosec theta from our formula will be given to be 1 over sine theta. So from here, you can recall that our sine theta was equal to 3 over 5. So from here, we are going to have that this is going to be equal to 5 over 3. How about tan theta? Recall the formula SOHCAHTOA. So from here, we can find our tan, which means opposite over adjacent. So from here, we can say that our tan theta will be equal to opposite, which is 3, all over adjacent, which is 4. Lastly, let's find our sec theta. Sec theta is equal to 1 over cos theta. We already have that our cos theta is given to be 4 over 5. This entails that we are going to have 1 divided by 4 over 5, which is the same thing as 1 times 5 over 4. Hence, we are going to have that our sec theta will be equal to 5 over 4. Now, let's proceed to the next question. We are given that cos theta is equal to negative 5 over 13, given that sine theta is greater than 0. We have to find sine theta. Now, our quadrant is as shown. From the question, we can notice that cos is negative and sine is greater than 0, which means that sine is positive. Now, if you look at the quadrant, you see that that falls in quadrant 2. Recall that cos theta is the same thing as adjacent over hypotenuse. It therefore entails that our adjacent is minus 5, while our longest side, the hypotenuse, is 13. Hence, we are going to find the opposite. So from our Pythagoras theorem, we are going to have that c squared is equal to a squared plus b squared. This entails that the longest side, 13 squared, is equal to minus 5 squared plus x squared. This is going to yield 169 equals to 25 plus x squared. From here, we are going to have that our x squared will be equal to 169 minus 25. X squared is equal to 144, which entails our x is equals to 12. This means that our x is going to be equal to 12. How do we find sine theta? Recall that sine theta is equal to opposite over hypotenuse. So this entails our sine theta is going to be equal to 12 over 13. So therefore, sine theta is equal to 12 over 13. Do well to like and subscribe to my channel. Thank you.